The floor is yours.
Okay, I had to figure out how to unmute, sorry. Well, thanks for the invitation to present. I'm going to present a joint paper with Hal Kruger, colleagues from Penn, and Yana Park, who is a student of Hal's and Dirk's many years ago, on coalition-proof risk sharing under frictions. I see. Okay, so all institutions face the challenge of deterring opportunistic behavior. Bad behavior is punished, good behavior is rewarded. And we're used to thinking of this as an equilibrium, which we can think of as a self-enforcing agreement, which is based on a shared belief in future cooperation. But this shared belief and the belief of future cooperation can also encourage coalitional deviations, undermining the institution. Groups of people could get together and act against the interests of the broader community in their own interests. And that's a challenge of coalitional deviations that many people have thought about. And the point that we want to make in this paper is this belief in future cooperation is not easy to achieve. It can be difficult to achieve. And we're going to be thinking about groups of agents as having a sense of community, social capital, which describes how easy it is for groups to have this belief in future cooperation. And what we're interested in doing is exploring the role of this shared belief in future cooperation in allowing agents to reach improving agreements. And we're going to do this in the context of risk sharing. So this is obviously a big topic, and many people have thought about this. I mentioned coalition deviations, and of course there's a larger literature where people have thought about coalition deviations before, and the related notion of renegotiation proofness. I have a few of the critical references up there. Risk sharing also, there's a large literature concerned with the possibilities of sharing risk when people can't sign contracts. And what's going to be particularly important for us is that the outside options available to agents in this risk sharing are going to be endogenous. Lastly, there is an important paper by Jennecott and Ray, which also looks at risk sharing under the threat of coalitional deviations. And I'll mention how we're related to that paper as we go on. So before I get into the structure of the paper, what is the main results that we have? Well, the easiest way to think about what we have is to think about a comparative static exercise and just asking what happens to the efficiency of risk sharing as I vary the amount of social capital in the community. And I'm going to be, again, thinking about the social capital as the ability of the groups to reach agreements. When we start off with no social capital, the groups can't reach any agreement whatsoever. Well, if groups can't reach agreement, then coalitional deviations aren't a concern. But at the same time, ex ante, no agreement is going to be reached. Now, as we increase a little bit the ability of the communities to reach an agreement, conditional on an agreement being reached, they don't have to worry about coalitional deviations because they will face the same challenge as the original group. So that means first best insurance is going to be possible. As we increase the ability of our communities to reach agreement, as we have higher social capital, now coalitional deviations become a binding constraint. And when it's a binding constraint, equilibrium insurance is no longer going to be first best. We now need to provide incentives for those rich agents who are contributing some current income to the currently poor agents to stay within the agreement. And this will generate imperfect and non-stationary insurance, where poor agents who have been poor for longer periods of time receiving less insurance than those agents who are just recently impoverished. Nonetheless, when we look at the ex-ante value of the insurance that is provided, this ex-ante value is going to be strictly increasing in the amount of social capital. As we increase the social capital even further, we're going to hit a critical value where now further increases in the social capital have no value in terms of ex-ante value. The problem is that now the threat of coalitional deviations are so strong that we need to engage in some form of utility burning in order to deter future deviations. And I'll explain more detail later on what exactly I mean by this last point. So that's the broad brushstrokes, what the paper is about. Now let me turn to the specifics of the economy that we're going to be looking at. We're going to be looking at a continuum population of ex-ante identical risk-averse agents who are subject to income risk. In each period, each agent has an idiosyncratic income shock with probability 1/2, he's poor, he has low income. With probability 1/2, he's rich, he has high income. I'm going to denote by capital Y the set of possible income realizations, and the aggregate income or the average income is just going to be Y bar. This is the first difference from Jenner, Cotton, Ray that I mentioned, who are looking at a finite population. This is important because when we look at any deviations in this kind of economy, since we have a continuum population, when we have a deviation by a large coalition, and by large I mean a positive measure coalition, there is still no aggregate risk. So we're not changing the aggregate risk characteristics as we look at sub-coalitions. On the other hand, if we looked at a finite economy, sub-coalitions are necessarily going to be riskier because there are fewer agents over which to share the risk. Individuals are going to have a strictly concave utility function, and each individual is going to maximize the average expected discounted sum of utility with a discount factor beta. That's how you can tell I have macro co-authors. The autarkic utility, which is my benchmark, is going to be VA, and that's just 1/2 of the utility from being poor plus 1/2 from the utility of being rich. So that's the economy that we're going to be looking at. The only other ingredient that we need is to describe how we're modeling coalition formation, deviations, and what do I really mean by social capital. Well, we're going to start off our economy in period 0 in the planning contracting period. This is when the grand coalition is getting together and trying to agree on their risk sharing. I'm going to model the difficulty of reaching agreement and having these coordinated beliefs in future cooperation in a very crude way. I'm just going to assume that my community is characterized by a probability pi, and this pi describes the probability that an agreement is reached. I'm not describing which agreement, this is just the probability that an agreement can be reached. With probability 1 minus pi, no agreement is reached, and then the agents are stuck in autarky forever. So this is the friction that is in the title of the paper. The friction is the difficulty that the coalition has in reaching an agreement. Well, let's suppose that our grand coalition does reach an agreement. So
the pi does not depend on the coalition for all.
No, the pi is going to be constant. I'm going to assume that pi is a characteristic of the community, and it'll be the same probability pi for both the original coalition and all possible sub-coalitions.
Okay.
So now let's suppose that the coalition does form. That means they've agreed on this risk sharing. And now let's think about what happens in the first period. In the first period, if we're doing some risk sharing, the rich people are sacrificing some current consumption in order to provide some additional income to the poor people. And these rich people could think, well, with probability 1, since half of the community is rich, that's still a positive measure set of agents, they certainly could, in principle, consume all of their current income and then try to do insurance tomorrow. And this might be an attractive deviation. The difficulty that this deviating coalition faces is that they, again, just as in response to Pradeep's question, they've got the same probability pi that they may not succeed in reaching an agreement. And if they fail, then they're stuck in autarky forever. So the important sequencing here is that the coalition, when it decides to deviate, does this knowing that there's some chance, 1 minus pi, that their deviation will not result in a successful agreement on future risk sharing. It may, and it will succeed with probability pi. So any negotiations that are occurring within these coalitions, whether it's the original grand coalition or any deviating coalition, all of these negotiations are being done knowing that there's a possibility that in the future, there could be further deviations by sub-coalitions. Okay? And so this has this flavor, as I indicated earlier on, of some sort of renegotiation proof of constraint that I'm going to be introducing in 2 slides. Before I give you the specifics of how we capture this coalition proofness or renegotiation proofness of constraint, let me just introduce a bit of notation that'll help us. So the object that everybody's negotiating over is a consumption allocation. And without loss of generality, I'm going to assume that all agents with the same sequence of income shocks are going to be receiving the same consumption allocation. So if I look in the original period, all agents are ex ante identical because the first income shocks occur in period 1. And the ex ante utility to my representative agent is just going to be the expected discounted utility from the consumptions that this allocation is promising in every future period. Y super tau is the history of income shocks. So superscripts will indicate histories, subscripts will indicate periods. And so that W0C that you see there is just the expected utility of my agents in period 0 from this promised sequence of consumptions. The deviations are going to occur at different histories. And for the purpose of this talk, I'm just going to look at deviations by coalitions that are indexed by the same history, because these are all going to be ex ante identical agents. So at any history Y super T, there's going to be a positive measure set of agents who have received that history. And this positive measure set of agents are receiving the same promised consumption in the current period, Cy of T, and they're all expected to receive the same sequence of promised continuation consumptions given the possible different sequences of income shocks that they'll receive in the future. And so WYT of C is their continuation utility in period T. And we'll be comparing this continuation utility with the utility that a deviating coalition could receive. Well, what can a deviating coalition receive? In this period, they will consume the current income from that sequence of income shocks. That's Y sub T. Then, because they've decided to deviate, they only reach an agreement with probability pi, and then they'll be getting the ex ante utility from whatever the consumption allocation is that they've agreed upon C. And with probability 1 minus pi, they'll be getting the autarkic utility. Okay, so is there any questions on the notation or the where we are so far? Excellent.
I'm slow. Can you just redefine history?
I'm sorry?
Just define history for me again.
Sure. So for each agent, their history is going to be just the sequence of income shocks. Whoops, I'm sorry, I'm going the wrong way. Good. For each agent in period T, he will have had a private sequence of income shocks.
I see.
And we're in a continuum economy, and so there's going to be a positive measure set of agents who have received any particular sequence of income shocks.
So they observe the measure.
So in terms of what we can think about these income shocks, these are all going to be public. So there's no issue here about truthful reporting of your income. So the consumption allocation that people receive, they know what consumptions they will receive under the consumption allocation given their sequence of income shocks. So all of the income shocks are public.
Okay, but I also know how many people on my path got low income or high income in each period, do I?
Well, everybody on
the measure of people.
But you also know how many people received the different income shocks.
That's okay. That's what I.
We're in a continuum economy. The fraction of the population who receives each income shock is just going to be described by the probability of that income sequence.
Thank you.
Excellent. So, what is the object that we're going to be looking for? We call this our equilibrium. So, what we're after is a consumption allocation, which is going to maximize the ex ante utility of my agents in period 0, subject to 2 constraints. Well, there's no storage in this world. So in every period, aggregate consumption cannot exceed aggregate income. And it's just easiest to measure everything here in per capita terms. So expected consumption in period T has to be no greater than the per capita income. And then we need internal incentive feasibility. So this is where we're going to capture our notion of renegotiation proofness or coalition proofness. And so let me just talk through, this is a necessary condition for any sensible notion of coalition proofness. So let's suppose that in period 0, our community has agreed on a consumption allocation that's going to describe everybody's future consumption in every period. And since they've all agreed on it, they've all said this is a self-enforcing agreement. This is what we expect to get in every period. And now let's suppose that there is some history, YT, with the following property, that if I look at the coalition of agents who received that sequence of income shocks, their continuation utility from the agreement is less than the utility they would receive from deviating, consuming their current income YT, and then receiving the continuation utility from defection. Now, what's the continuation utility from defection? With probability pi, they're able to agree on a new consumption allocation. Now, whatever new consumption allocation they agree on, one potential agreement they could reach was the original self-enforcing consumption allocation C. So let's suppose that if they did agree on that, then in their continuation, they get pi W0 plus the 1 minus pi times autarkic. And this deviation utility was strictly greater than the continuation utility. But that means the original consumption allocation was not self-enforcing. So this is a necessary condition. The way I've written this is that I've got the same consumption allocation C here and here. And so I'm calling this internal incentive feasibility. And so this is consistent with what von Neumann and Morgenstern called internal stability, Farrell and Maskin called weak renegotiation proofness, because we're not looking at all possible allocations. We're just fixing attention on the current agreement. So this is a necessary condition for something being in equilibrium, but we could think about stronger notions, and I'll get to stronger notions in a few slides. To fix ideas, let's first ask a simple question. When can we get full insurance as an equilibrium of this economy? Well, first best insurance just involves every agent receiving as consumption the per capita income. So even though half the people are rich, half the people are poor, all agents in every period have identical consumption. If complete insurance is in equilibrium, then it has to be the case that the rich agents do not want to defect. So we take all of the rich agents, they consume their current income H, and then tomorrow they get first best insurance with probability pi and autarkic utility with probability 1 minus pi. If pi is too large, we're not going to have an equilibrium. In particular, to fix ideas, think about pi equal to 1. If pi is equal to 1, then the rich agents face no punishment from not contributing to the consumption of the currently poor agents, because tomorrow they can completely self-insure and receive first best insurance. And so there's no incentive to contribute insurance in the current period. So we need an upper bound on the amount of social capital in order for there at first best to be an equilibrium agreement. And this upper bound on the amount of social capital, I'll call pi FB. And at that critical value, the social capital, this is the critical value so that the internal incentive feasibility constraint for the rich guys is just binding. They're just indifferent between the following thought experiment. If they continue in the agreement, they're contributing to the currently poor agents, and they will receive first best insurance for sure tomorrow because they're in the agreement. If they defect, they can consume their current high income, and then they only receive a lottery over first best insurance and autarky tomorrow, where pi FB is the probabilities on this lottery. Of course, the poor agents never have an incentive to deviate because they're receiving current higher consumption and they're getting first best insurance in the future. Since these incentive constraints do trade off current consumption with future consumption, we of course need agents to be sufficiently patient to have any hope of insurance. And so beta FB is the critical value of the discount factor for first best insurance. Excellent. So our
George?
Yes.
I have a question. So if you can go back to the previous slide. So it's clear that this condition is necessary for first best insurance. Why isn't it sufficient?
Which one? The
condition you have here.
So if pi is less than or equal to pi FB, then that will be sufficient for first best insurance.
Oh, okay. So you mentioned that this condition was necessary, but it's also sufficient, at least here in this analysis.
That's right.
Okay.
It's a little waffling down here. It's when beta is too low, then we can't get first best insurance at all. If beta is above first best insurance, then we may or may not get first best insurance, depending upon the amount of social capital.
Right. But in any case, the condition you get is this is an if and only if, but that's okay.
Well, as long as pi is low enough, that's exactly right.
Right. Okay.
Okay, so our goal here, though, is not to understand when first best insurance is in equilibrium, but to characterize what are the risk-sharing possibilities in general, which includes the possibly incomplete insurance. So I've reproduced the definition of equilibrium here, and I've highlighted in green the thing that makes this an interesting problem. So if we think about looking for consumption allocations that maximize the ex-ante utility of my coalition members, they're faced with the following trade-off. By choosing a consumption allocation that makes their ex-ante utility very high, that looks great from an ex-ante point of view. But at the same time, this consumption allocation then makes it more attractive for coalitions to deviate, because as we increase W0C, which is here in the objective function, we're also increasing W0C here, which is on the right-hand side of the constraint. And as we increase W0C, we're making this constraint more demanding. So in general, it's not obvious that this maximization problem even has a solution, because whatever C that we select has the danger of, as I discussed earlier on, it could contain the seeds of its own destruction. And so we need to worry about that. The other mathematical issue here is that this, even separately from existence, characterization is complicated, because this is not a concave programming problem, because the constraint correspondence is not convex valued. We have a concave function on both the left-hand side and the right-hand side of the inequality describing the constraint. So that's a bit of a pain. So how are we going to try to get a handle on this? We'll get a handle on this by looking at what I call exogenous incentive feasibility. So I'm now going to take a minor detour, where before we had an endogenous outside option. Think about this value to a deviating coalition as the outside option. And it's endogenous in the equilibrium notion because it depends upon the agreement that's being reached. So now let's suppose instead I fixed my capital F, which I'm just going to treat as an exogenous value to the deviating coalition from the future. Then for any fixed F, this exogenous incentive feasibility problem is a very well-behaved problem, which is easy to solve. And I'm going to call the value of this problem V star of F. Notice that whether this problem is well-defined or not now only depends upon whether CF, this is the set of consumption allocations that satisfy the constraints, is non-empty or not. If I just chose my capital F as being too large, then it's going to be empty and I won't have any solutions. If, on the other hand, F is small, for example, I could set F being equal to the autarkic utility level. What's the intuition there? The intuition there is just that if any coalition tries to deviate, they can consume their current income, but then they're stuck in autarky for sure. Then, as long as players are not too impatient, then we'll be able to get some insurance. And no matter how impatient players are, autarkic consumption, that is no risk sharing, will always be feasible. But there may be other consumption allocations which are feasible. So why is this exogenous incentive feasible problem the right problem to look at? Well, think about doing the following exercise. Just arbitrarily fix F at some point where the constraint set is non-empty. Solve the problem, we get a value V star of F. So this is the value, the continuation value that the coalition would receive if it's successfully coordinated. Then the ex-ante value from the deviation would be pi times that value, plus 1 minus pi times the value of autarkic utility. Let's suppose that when I do that calculation, I end up with my original F. That is, F was a fixed point of this problem. Well, then F turns out to be the equilibrium value. Why? Well, in fact, such an F describes a stronger notion of equilibrium, because V star of F is we're optimizing over all possible consumption allocations that satisfy this constraint. So indeed, that kind of solution generates a consumption allocation that is going to be externally incentive feasible. In the language of Von Neumann and Morgenstern, it's externally stable. This would be strongly renegotiation proof in the language of Farrell and Maskin. What we're saying is that we've found a consumption allocation, C dagger, with the property that it is robust to the threat of any coalition seceding, and after the secession, if they could successfully reach an agreement, they would then re-optimize over all possible consumption allocations. And if C dagger is robust to this stronger notion, it's indeed going to be internally incentive feasible. And so this would give us our equilibrium. And so I've got now a sufficient condition to get an equilibrium, and indeed to get a stronger equilibrium notion, that is this fixed point. And so we're interested in when we can get a fixed point. So let's look at that. In order to understand when we can get a fixed point, we need to understand the nature of the constraint sets, the collection of consumption allocations that are exogenously incentive feasible against this F. As I mentioned earlier on, if F is equal to autarkic utility, since just specifying consume your current income is feasible, and it's incentive feasible against this threat that you're just going to get autarkic utility, we know that if F is equal to VA, that we're going to get a non-empty set. Can I get a non-empty constraint set for larger values of my exogenous feasibility constraint? Well, let's suppose, first of all, that players are impatient. How impatient? Let's do the following thought experiment. Let's suppose that we had an agent who had high income today for sure, and he knew that he was going to have low income tomorrow, and then he died. So it's just a two-period problem. And now let's suppose I gave him the option of saving epsilon when you have high income today and consuming an additional epsilon tomorrow. Bit of income smoothing. If beta is small, so if beta is such that this inequality is satisfied, then the player is so impatient that even that straightforward income smoothing is not attractive to the agent. He doesn't want to do it. This means that in our current setting, risk sharing is never interesting. And the constraint set will be empty for any capital F above VA. So now let's suppose that agents are just a little bit more patient. If we're just a little bit more patient, that means intuitively we shouldn't be able to do that much better than autarky. Well, here's an interesting consumption ladder, which does a little bit better than autarky, does a little bit of risk sharing, but in a very particular way. I'm going to ask every agent when he's rich to sacrifice epsilon of his income. And remember, in every period, half the population has high income. Now, rather than giving or sharing this income equally amongst all the poor people, what we do is we give all of this income, so that's half epsilon, is going to be shared over only those agents who are recently poor. And that's only a quarter of the population, because a quarter of the population had high income in the previous period and now have low income in this period. And so they'll get L plus 2 epsilon. So this is a way of doing risk sharing in a way that increases the utility of the agents who are currently high, because they're worried that with probability 1/2, they'll be poor tomorrow. And so I'm skewing the risk sharing towards those agents who are just recently poor. And this is the consumption allocation that shows us that, in fact, F bar will be strictly greater than VA when beta is greater than that inequality. Good. So now let's look at some pictures to get the fixed point, because you know there are pictures when we're looking for fixed points. So the red line, so on the horizontal axis, I've got my exogenous value of the outside option. On the vertical line, I've got values. VA, this is autarkic utility. V star of F, remember, is the ex ante value from the optimal risk sharing that's agreed to when we've got the coalitional deviation constraints, and the coalitions think they can get F tomorrow if they deviate. So this F doesn't depend upon pi. This is just the exogenously specified value from the deviation. Well, if the exogenous outside option is very low, if it's smaller than some value, then we can get first best insurance. And so that's why we've got this region over here. We're getting first best insurance until we hit a critical value, FB. At this point now, the rich agents are just indifferent between participating in the agreement of first best insurance and deviating. As we increase F, now the first best insurance is no longer consistent with the equilibrium because we're violating the constraints. And so that means that we have to reward the high agents a little bit to keep them in the agreement. So that means there's less risk sharing going on. As we increase F, the constraints become increasingly tighter. And so the value of the program is falling until we reach a critical value of F bar where the constraint set is just non-empty. Any larger value of F and the constraint set is empty. And critically, V star of F is going to be greater than F at that critical value. So now let me put in my mapping T. I've chosen a value of pi, so that when I take the convex combination of V star of F and T, we do indeed get a fixed point, and there's my fixed point F of pi. So that's the equilibrium value of my equilibrium for that particular value of pi. And as you can see, as I vary pi, I'm just going to be smoothly moving my green line. And so the fixed point given by that green dot up and down this 45-degree line. In particular, as I lower pi, the ex ante value of the equilibrium is falling. F pi is going down until we're going to hit this point, this orange point. There we've got the first best level of social capital. This is the point where once we reach an agreement, we do get first best insurance. And as we further lower pi, we're always getting first best insurance if we reach an agreement, but we may, there's a low probability of reaching the agreement, so the ex ante value is lower. As we increase pi, we're going to hit some critical value pi bar. And at that critical value pi bar, that's going to give me the maximized value of the equilibrium. This is the highest amount of social capital that is consistent with my fixed point, and so consistent with my strongest notion of equilibrium. Any higher value of social capital means that if my coalition could reoptimize after they deviate, they will in fact want to deviate. And so we won't have my stronger notion of equilibrium. I'll get to our weaker notion in a minute. Good. So this slide summarizes what I've been talking about so far. If players are sufficiently impatient, there's no risk sharing. If players are patient, and if the amount of social capital is not too large, the equilibrium is unique, its ex ante value is increasing in the degree of social capital, being maximized at F bar at that critical value pi bar. And then the theorem also asserts that for larger values of social capital, equilibrium still exists. The allocations are no longer unique, but they all have the same ex ante value of F bar. And we show this through construction, and I'll get to that in a few minutes. Before I get to that, let me just give you a quick description of the equilibrium allocations when the social capital is so large that we can't get first best insurance, but it's not so large that we're above pi bar. The name of the game here is to discourage secession by the rich agents. So we don't have first best insurance, but we do have some insurance. So the rich agents are contributing some of their current income to the poor agents. The question is, how is this insurance distributed over the currently poor agents? And as I hinted at earlier on, we want to do this in a way that it increases the current utility of the rich agents because we don't want them to deviate. And so we skew this insurance towards the agents who are more recently poor. So we're going to
George, again,
yes.
My unpleasant task to remind you that you have 10 minutes.
Ah, excellent. Thank you, Sandro. And so we're going to have this non-stationary insurance where the agents who are more recently rich, even though they're currently poor, have higher consumption than those agents who've been poor for a long time. And so we've got this consumption ladder where consumption discretely falls for each new realization of low income, but it doesn't fall forever. There's going to be a consumption floor where it's actually constant. At some point, if you're being poor for a long time, you're still receiving some insurance, but not that much. Why can't the consumption fall anymore? Well, you always have the option, if you're poor, from seceding. It's true that now you give up current insurance, but the benefit is that there's still a positive set of agents, a positive measure set of agents who've been poor for a long time. They could deviate from the coalition and by so doing, restart the agreement. And they might be better off. Good. So now, in my last few minutes, what do we do for those agents, those communities where there's a large amount of social capital? Well, we do have an equilibrium. So we know that that means that the ex-ante value of the equilibrium can't be any larger than F bar because that constraint set math-cal C is non-empty. We also know that that ex-ante value of the equilibrium comes from a convex combination of the value of that consumption allocation and autarkic utility. And so that means that an equilibrium, W0C, has to be smaller than V star of F bar. This we call utility burning. There is this value that the coalition expects to receive if they deviate, but that value that they're getting when we solve the exogenous incentive feasibility problem gives me consumption allocations that the agents can't agree to. Because if they do agree to that consumption allocation, they'll be getting an outside option for the coalition that is greater than consistent with equilibrium. So what does this consumption allocation do? Well, there are lots of different ways of generating this utility burning. An easy way is to think about a consumption allocation that does what? Well, think about a consumption allocation that exactly hits F bar when we had pi equal to pi bar. We can call that C dagger. Now, what am I going to do? Social capital is higher than P bar, so C dagger is not going to work. So instead, I'm going to not do any risk sharing in the first couple of periods. I'm going to postpone the start of risk sharing. By postponing the start of risk sharing, I'm basically describing a consumption allocation in which the agents are investing in the relationship. They're investing in the relationship by burning utility. Why is this a good thing? Well, while we're not doing any risk sharing, there's no incentive for any coalitions to deviate. Once we enter the risk sharing period, now my rich agents know that in the future, if they're poor, they'll benefit. What happens if they now, as a rich coalition, defect from the arrangement? They can consume their current high income, but now they have to restart this agreement from the beginning and postpone their risk insurance. And this trade-off is exactly just enough to give me equilibrium. Excellent. So in my last, second to last slide, I'm just going to summarize in this picture what we've just seen. So on the horizontal axis, I've got the discount factor. On the vertical axis, I've got the amount of social capital. And we're seeing that when the discount factor is too low, there's no insurance, no matter what the value of social capital is. Then as we make agents a little bit more patient, we still can't possibly get first best insurance, but now we can get some insurance. And as long as the social capital is not too large, we can get efficient insurance consistent with the coalitional constraint. So that means no utility burning. The value of the consumption allocation is exactly equal to V star of F. If the social capital is too large, then we're going to have to do utility burning. And then as we increase the degree of patience of the players, they're more willing to make this trade-off. Then the region of the dark blue region increases, and then we'll eventually reach a region where we can do first best insurance. And here's a slide that summarizes everything I said, but I think instead I will say thank you and ask if there are any questions.
So I can ask a question. So I imagine there are different ways to do the utility burning, and you chose this postponing the risk insurance because that's the easiest to self-enforce, given how you have defined the self-enforcement.
Yeah. So we actually, in the paper, we provide two different ways. This is the way I prefer to think about it because it was a clean way to do it. Hal, my co-author, prefers another way where we actually burn resources. So the other way to do this is, so again, we solve the problem at pi bar f bar. That gives a particular consumption allocation. We get non-trivial risk sharing in the beginning. So the rich agents are sacrificing current income and giving it to the current poor agents. Now we do resource burning. We still take away income from the rich guys, but we don't give it to the poor guys. So what will happen for the first couple of periods is that we still effectively tax the rich guys. The people who are always born poor are getting screwed. So this is, I think of, well, okay, I was going to say something. This is like the Republican version. Okay.
This is recorded.
Exactly.
We can edit later, don't worry.
So there's lots of ways.
But George, but in that case, I mean, I also like the way you like better. I also like it better because this what you are doing by postponing the resharing here in that scenario, you are using all your self-enforcement constraints, right? So you're making sure that that postponement is coalition-proof and so on. Right. Whereas if you are just burning money, the way you describe it, like the second way of doing it.
No, so that one also uses it. And I mean, what's
you can also
So, and the way that, and it's kind of nice because since we start still using the consumption allocation that I got from solving F bar, that has to satisfy all those coalitional constraints.
I see. So I think of the rich people just burning some of their money, and exactly. it's incentive compatible for them to do it. So it's not that you have a third party. Okay.
Right. Exactly. And both do have the property that they're effectively making sure that if you in the first period are poor, you're being treated badly. That's the critical thing that you need to do to make these coalitional deviation constraints work, right? So that when I, as a coalition, I deviate, it's true that I can consume my current income, but the threat always is that if in the next period I'm poor, which occurs at probability 1/2, I do not get it. I only will receive insurance the first time I get high income.
Right.
All these allocations have the property that you never want to be born poor.
I think that's always true.
I think that's what, yeah.
I have one question.
Yeah.
Is it correct that in your model, if you take any sub-coalition of players, as long as it has positive measure, you could apply the same analysis, right?
Exactly.
The mass of the society doesn't matter here.
Exactly. And that's, I mean, this is definitely a shortcoming of the analysis. It's what makes this problem tractable for us. But for sure, and I should, for example, if you think back to, I mentioned the Jennecott and Ray paper earlier on. They're interested in a similar problem with two differences. For them, pi is always equal to 1. And I should have said this at the beginning when I was talking about the literature. All of the literature on coalition-proof deviations, renegotiation proofness, they always fix on pi is equal to 1, whereas we really wanted to look at this trade-off. But separately from pi is equal to 1, what Jennecott and Ray do is they look at a finite population of agents so that when any sub-coalition deviates, they have less ability to share risk. So they get an interesting trade-off there in terms of, that's one of the reasons sub-coalitions might not want to deviate, is that they're necessarily giving up risk-sharing possibilities.
Yeah, no, I was worried about the fact that if you have heterogeneity in pi, then different coalitions, different sub-coalitions can actually do better in terms of self-insurance. So there might be an incentive to split the society between people with high social capital and people with low social capital.
Right. So, I mean, exactly. And you might also have thought, for example, that pi should be a decreasing function of the measure of agents. So that when a smaller coalition tries to deviate, it's easier for them to reach an agreement. I agree completely. And, you know, we were just so relieved to finish this. We're still recovering from that. Then we'll go back and think about it.
Okay. Then if there are no further questions, I think we can declare.
Can I ask a question?
Is there another question?
Yeah.
Yes. George, so I guess I was wondering, so you focused on comparative statics in both the discount factor and the extent of social capital.
Right.
In this context, it seems also interesting to sort of think about issues about what happens when the risk aversion changes, right? So
Excellent question.
You know, the first best is sort of changing. So I guess you'd want to do something like look at, I don't know, what fraction of the first best do you obtain, or something like that?
Indeed. And so the general theoretical analysis is just done for arbitrary, strictly concave utility functions. We do we're able to do a little better in terms of characterizing things exactly at pi bar, and we do even better when we look at CRA utilities. And in the paper, there are some computational exercises to look exactly at how the consumption allocations vary when we change risk aversion. But I can't remember exactly what they do, but you're exactly right. I mean, there are some things that we can say as we vary the degree of risk aversion. And my colleagues who did the computation assure me that it was interesting, but I just can't remember what they were.
Okay.
Okay, I'll look at the paper. Thanks.
Yeah.
More
Great.
questions. Good, then I think we can declare over this presentation and the first part of the morning session. I'm